I just want to close with telling you a little bit about what experts do when they're training deep neural networks. So you should always start off by training your neural network with only a few iterations and watching that progress before you let it run for hours and hours. And while you're watching this early progress, you can change various parameters in your training. So you can add momentum, which is something that we did in this tutorial and is also implemented in tutorial 3. And you can look up the details of that if you're interested in it. It can be very helpful for optimization. You can also vary the size of the random weights at initialization, and this was actually helpful in this tutorial, and you'll see that this is also implemented here, and you can change the size of those weights and see how it potentially changes how well you can decrease your L1 penalty, the sparsity penalty. When you're trying to find the optimal learning rate, an easy way to do it is to try to increase the learning rate as much as possible until the network explodes, and then decrease it after that. And just stay as close to that explosion point as possible so that your learning rate is large and you're exploring a lot of the parameter space, but not exploding. And also other things people do is they anneal the learning rate up at the beginning, starting with a small learning rate and annealing up the first few epochs. And then also you can anneal the learning rate down at the end, making it smaller as the epochs go on. And these kinds of schedulers are implemented in PyTorch, so it can be fairly straightforward to use them in your own code. You can also decrease potentially the batch size when you're running through the deep network, and this we didn't have time to discuss today, but it's in the appendix of tutorial 1. You can look up more about stochastic gradient descent rather than gradient descent, which is particularly important when you have a really large data set like ImageNet with 1 million images. You can't run all of those images at the same time, so you use batches. There are also some myths that people have about deep networks, which may or may not be true. Some people say bigger networks overfit more. That can depend a lot on the architecture and whether or not you have, for instance, skip connections or you're using residual networks. Some people think that certain optimizers perform better, like Atom or Attograd, and you can try these different optimizers and see if they work better or worse for your specific problem. People also say that stopping the optimization early is important, and so that might be because you don't want to overfit too much to your test data, but hopefully you have enough regularization in your network that that's not a problem, and your test and your training loss decrease somewhat similarly across iterations. And then also in the past, people often use dropout, but it tends to be the case that batch normalization will work better for you. So I hope this leaves you with some tips and tricks to go off in the future and use deep networks in your own research.